Today we start working on a small terminal tool to practice typing. We are going to be using Rust as our main programming language, and this is the end result that we would like to achieve. The whole terminal window is used to display our practice session. The text is in the middle. We can increase font size if we want to, decrease it. Everything adjusts on the fly. We can type in the text, we can make mistakes. The text has to be typed correctly fully for the practice session to end. Once the whole text is typed in, it should show the statistics, so some typing speed, words per minute, and your accuracy. And then you can either quit the program or restart with a new typing session. So as I said, we're going to be using Rust, and the library that will enable us to do the thing I just showed you is called Ratatui. A very nice library that enables us to create very nice user interfaces in our terminal. This library is based on Crossterm, which manipulates any terminal, well, hopefully like any terminal. It says all Unix and Windows terminals down to Windows 7. So hopefully it will work for you the same way as it does for me. So I guess we can get started, and as usual, we need to create a new repository. Let's call it TypeGym. We'll add everything afterwards. We can add some basic readme, git ignore for Rust, license later on. Let's create it, grab it, and clone it. Once it is cloned, we jump in, we run cargo init, and then we can instantly use cargo run, and we get our hello world running. Just so you know, I have an alias cr which does cargo run, so that you know why I type cr, and it executes my program. That's just an alias, as I do mostly in all of my videos. So let's see. First of all, let's define our initial set of dependencies. So we will use Ratatui, which is currently sits at 0.30, and there was Crossterm, which is at 0.29. We will mostly not need any documentation related to Crossterm. Everything is going to come from documentation of Ratatui. Specifically, there is a very nice set of examples that they have, and unfortunately the link is somewhat outdated, so you can just go to the top of repository and find an example folder there. And here they have hello world. We can jump to its source, immediately show the main, how it's done. So this is everything you need to get started with the hello world example. Pretty much what you see right away is that they use color Irie, or however it is pronounced, which is, I think, somewhat of a fork from anyhow, which will allow us to handle errors. Some error report handler with some error reports. Right, so we are also going to be using that. So let's add it as well. Color Irie, and it is 0.6. Right, so this is enough for our first couple of episodes, I believe. So we can jump to our main and do the same thing as the hello world example does. we return the result now, which is going to be okay. With void, we need to use color irie result. Now let's see, no errors reported. We can run it. Our dependencies are being built, and our hello world is shown as before. Now this example shows us that the first thing that we need to do is we need to install color irie. So we'll do the same way in our code as well. Now we can start thinking about how our main is going to look like. First of all, because it's a terminal tool, it will receive some command line arguments and we would need to parse them. This is something that we will do in the future in one of the next episodes. It will look something like this, like config parse, right? We will use probably the most common library for that, named clap. For now, we don't have it. We will use mod config, so a new file where we can define struct config. We can derive debug, and for now we can just say that, hey, parse command line arguments via clap. For now we can just simply provide config by hand, and to do that we can say config is simply config new. We can import it and then generate this new function. Let's see. Just for now it will be empty. We will see whether we need to add anything, and we will add it there as we go. So once we have our config, eventually it will be parsed from command line arguments, merged with some defaults. For now it's just an empty thingy, and then we enter our main loop. The first thing that we do in our loop is we get the text that we're going to be practice on. So let text is something like get text using our config, and probably just a reference. Config won't ever change, it's loaded once and then used for every practice session. So this main loop is actually looping our practice sessions. You can do one practice session, start another one, cancel the existing one, start yet another one, or quit the whole loop once you decide that you're done with practicing. Once we have the text, it can be either some nonsense generated by us, as you saw in the initial preview of our end result, or it can be some lines read from a file, so that you can practice on something that you're interested in. Basically anything is possible here. We once again can set that we're going to use text module, going to create it. We can say that there's going to be a function get text, which is going to be provided with config, and it will return some yet again result string, because we're most likely going to be reading some files in the future. So we can once again use color irie result, and then for our initial setup, instead of trying to generate nonsense or read some files, we can instantly return some static text, right? So we can say okay, some text, where text is let's see, it's going to be statics str. Let's grab, let's say this section here, paste it here. I'll drop these comments and put it right here. So initially, all we are doing is we're returning text needs to go to string. And as this is unused, we mark it as such. So for the first couple of episodes, until we actually start generating our own nonsense text or read from files, we can always return this placeholder. Let's get back to our main. We can use this text. Yep. Once we have our text for the practice session, we need to set up a state from this text. So each practice session is going to have its own new state. Yet again, we need to create another module. Let's call it state, jump into it, struct state. Yet again, it's going to be empty for now, but we're going to be filling it in during this episode just to understand what kind of things we need to keep track in scope of a single practice session. Right now, I think we can write it out ourselves. Simple state, function new. It receives some text as an input, returns self. Right, for now we won't use that. Jump back to main, and we can say that state is there. Finally, once we have the text and the state, we can run our UI using our current state and probably the config. The run UI is going to be actually running yet another loop inside of it that is going to be drawing things using Ratatui. And as the end result, we would like to know whether we want to start another practice session or we can safely quit our program. So we can say that should loop is a result of our run UI, and if we shouldn't loop, then we can actually break. Now run UI. Run UI is going to be from yet another module. We call it UI. Let's create it. Public function run UI. We're going to be grabbing state and config. What are we going to return? We need to return the boolean, right? Because we want to tell whether we want to loop, should loop, or not. But at the same time, yet again, we need to return result, because a lot of Ratatouille things under the hood, they require this result, or they will return it, so we can propagate it to our main. Use color ID result for that. Then we have to import our state, we have to import our config. We can mark these things as unused. Oops, incorrect here and here. We can say, okay, false. Next, we can import this thing. And then get text is result. So we can extract this thing. Run UI is also result. So for the happy path, we are pretty much done with our main, except for this small to do, which is going to be like replacing this line with this line. But other than that, our main loop of our typing practice tool looks like this. And grab the config from command line. For now, it's just a placeholder written by hand, and then start the main loop where we generate or grab the text for the current practice session. We create new state for each practice session. We run the UI, which is going to be a loop in itself, which draws the terminal using Ratatouille widgets. It will, at the end, return us a flag whether we should start the new practice session or not. And if not, we can break and end our program. So let's see what we can do with run UI. Run UI is going to be responsible for displaying things and running our practice session app, so to speak. We can go back to the example and see that it uses some helpers ready to run using some run function which has terminal, and I found that custom widget example gives you a bit more interesting, more fully fledged and customizable things which we're going to be using. So the first thing we need to do when we are trying to run the Ratatui app is to get the terminal. So Ratatui init. Right, so it's going to be a terminal which has Crossterm backend, as we discussed in the beginning. That is the main dependency of Ratatui, and it's going to be work on stdout just because we're working with terminal via stdout. And at the end we should do the Ratatui restore. Once we're done, Ratatui restore. Next thing, it executes some enable mouse capture. This is needed for what? stdout. Let's import all this stuff. So mouse event capturing, I don't know like whether we will need that or not, we'll see. But in the end, once we're done, we can also execute like the reverse, saying that let's disable mouse capture, and probably that's it for setting things up for Ratatui, or maybe not. So really we will need to have some sort of app which is going to be run by Ratatui. So we will create something like app new, which is going to be based on our state and config. So that's simply things that we pass through to our app, and then we're going to be looping things. So that's the second loop I was talking about specifically for Ratatui, which is going to do what? Every single frame, so to speak, it's going to be drawing things. So we're gonna tell terminal draw, given some frame, we'll say, hey, app draw using this frame. Right, and draw is result, so we need to extract things. Then we can, once the app has drawn things, we can check if app should quit. Right, we can break from this loop. So this doesn't quit the program itself, it simply quits the practice session, so that we can restart if we want to yet another one. And once this is done, we can check for some input. I think we can get back to hello world example. Yeah. So we can use this like if event poll with some timeout. So duration from millis, 100 milliseconds. It's also result. So what does event poll do? It says that it checks if there is an event available. So if there is one, we would like to try and read that event. So if let event key code equal to event read, right? And event read is, I think, also result. Yep. So what we're saying here is that let's read an event because it's available due to the upper if, and if it matches an event key, so the key was pressed on our keyboard, then we can execute whatever we want, and for any other event we just do nothing. So at this point, we're going to tell that, hey, app handle key event, right? And this key code actually has a code, right? So it's a key code as in like which key was pressed, and it has modifiers, whether like Shift, Alt, Command, or any other modifier was pressed or not. So this is actually how our run UI is going to look like. Most likely it won't change unless we find that we're missing some Ratatui setup. But yeah, here the loop is pretty much just drawing the frame, checks whether we need to quit or not. If not, we can poll for the next event, whatever the user is typing. We are we're catching it, applying it. So next thing we need to do is to introduce this app, which is like a practice session. And let's define another module, app, create it, jump into it, struct app, let's derive debug as usual, and we have function new, it receives state, it receives config, returns self. So for now, once again, we are empty. State we need to import, config we need to import. We don't use this right now, we are not using this right now. So jumping back into our UI, import the app, and now it tells us, hey, that we don't actually have the draw method, don't have this should quit field, you don't have handle key event. So let's try and add those. Add field, then add generate draw method, and generate these methods. All right, so generated things for us. Let's see, should quit. So initially should quit false by default. Frame. Let's just import it this way. Next handle key event. Let me clean up these things. So code is actually key code, which comes from Crossterm. Modifiers is also Crossterm thing, and it won't actually return anything. Same as draw. Now, these are unused for now. We would like to probably draw something right here. To do that, we jump in back into Hello World example, and I think it has this render method which shows you the easiest possible way of showing something using Ratatouille. We're gonna just copy it, drop this to do, probably rename this to paragraph, import it. Frame is now used. So what it does, it creates a new widget, right? Widget to display some text with hello world string, and then it renders the widget into the frame using the area, the whole frame area. As we go on, we will see how we can split the frame area into smaller areas so that our text ends up in the middle. Right now it will be somewhere in the top left corner, and I think if everything compiles we should actually see things, but it says that, hey, we need to check this one. It says that terminal needs to be mutable, right? And we run it again, and this is our hello world. So the whole terminal has been cleared, the hello world string is shown. If I type anything, It says not yet implemented because it's to do. And really what we would like to show though in our draw, instead of this hello world, we would like to show this text that we have set up, this placeholder text. And for now, to do that, we need to somehow access it via the state that comes into our constructor. So let's start keeping state alongside the app. State. So state is going to be here. Probably we'll add config as well. We'll see whether we need that or not. For now, state is here. But the thing is that we haven't actually worked on state yet. It is empty. There is no text. We do pass the text as a constructor param. So let's try to think what practice session is all about. So first of all is the text itself that we want to practice on. We'll call it target, which is a string. So the text user needs to type. Next thing is we need to keep track of what the user has already typed in, right? So the current state of what's typed in, so that we can figure out what's left, whether there are any mistakes, and so on. So the text user needs to type, or the user has already typed in. We'll call it just input. What else? We, as I showed you in the beginning, we are gonna be trying to keep track of words per minute and some accuracy. To do that, we need to keep track of how many strokes, keystrokes the user did, how many of them were successful, so hits, and there is also the need to identify whether we want to loop, right, the whole program so that the next practice session can start, or we want to quit the program. So let's add a few entries into the struct. Let's see, what did I talk about? First of all, let's count the strokes. So the number of keystrokes user did, so overall. Then the number of correct keystrokes, we'll call it hits, and then a flag indicating whether we want to start another practice session. Pub should loop, I think we called it. Now, there is one thing missing here, is the accuracy requires number of correct keystrokes and the total number of keystrokes. So that is enough to calculate the accuracy. But to know the speed, the words per minute, we actually need to keep track of start clock, right? Some type, and end clock with some type. So pretty much we need to know when the typing session has started and when it has ended. To do that, we'll use option instant, right? Same for end clock, option instant. So this is going to be the time at which practice session started. So it's actually going to be first keystroke. So not when we displayed the text, but as the user starts to type in, we set the start clock. Because once we start the practice session and show the text, the user might just be looking at it, familiarizing. So really, I don't like starting the timer right away, but started as soon as the first keystroke is made. And end clock is the time at which practice session finished or was complete, fully complete, right? And hopefully this is everything that we need for practice session. We'll see whether we need anything else as we go, but for now it looks like everything, yeah, just everything. So let's see, we need to now set some defaults when we initialize our state. So target is going to be our text, right? We can mark it as usable now. Input, initially it's an empty thing to string because user hasn't typed anything. Start clock is none, we haven't started our practice session. Same goes for end clock, we haven't ended anything. Strokes is actually 0, user hasn't made any keystrokes. Hits same, and should loop, I don't know, like I think anything works here. Let's do false. All right, so that's our state. That's the things that we're going to be working on. We will add many more methods here to work with these fields, to manipulate some of them. For example, the input is going to be mutated the most. As we type things in, we need to work with the input. But yeah, let's get back to, I think it's to app. And as I said, instead of showing our hello world string, we would like to show the placeholder text. To do that, we can say self state target. We can't move, so let's just clone it for now. In the next episode, we are gonna be drawing things using Ratatui, using its widgets, manipulate it, place it correctly in the center of the terminal window. So we will build a more complex widget than this, and for now just cloning the target is fine. This will go away later on. Let's see whether this thing works. Some unused things, but yeah, we can see that our hello world has been replaced with our placeholder text, which is great. We can press any button. Our not yet implemented thing triggers. And probably before we leave, I would like to also show you how we're going to be handling key events in our code. Yeah, let's do that. So we have code and some modifiers. So let's think. So imagine we are already inside a typing session and we are pressing some keys on our keyboard. So we're handling each key press. So let's do that. Let's say match, let's name it key instead of code. I don't know, just sounds a bit better. Match key. We can say that it can be what, key code char. See, right? So we typed in some char character like A, B, C, D, whatever. We're interested in what else? We're interested in enter. We are interested in backspace, right? Because we make mistakes, we can make mistakes during typing. We would like to remove some characters. And then we are also interested in escape to restart practice session, start a new one. And just ignore all the rest. All right, so let's see. So if we detected that a character has been typed in, we need to tell our state, right? Self state apply char c. When we press enter, we need to tell the state apply char new line. When we press backspace, we can tell state apply backspace. And when we do escape, we need to what? We need to first tell the state should loop true and self should quit true. So let's talk about this escape first. So when we press, so we are inside practice session, right? It hasn't finished, it's actually running. So if we press escape, it means that we want to restart, we want to start a new practice session. So first, the flag should quit is set to true, which is then, where was it? In UI, right? We detect it and we break the inner loop, the loop that is responsible for Ratatui. Which then goes back into our main, right? And the second flag that was set to true is should loop, and because it's true, we're gonna restart this loop, generate new text, generate new state, and start another UI loop. So let's get back to our app. Again, we can just generate some methods. This one's already generated. Let's see. Let's do some cleanup here and here. So to do apply char. As we have so many to dos, it's nice to just know which one failed. Apply backspace. This one's unused. No return. Nothing to return. All good. And this one complains that what this has to be mutable reference, so which means that in UI app needs to be also marked as mutable. All right, so this is what happens during the practice session. There is also one more thing that we need to handle. You can see that modifiers is currently unused. So what we want to handle is two more things. So let me show you. Like if modifiers contains what? Contains modifiers control, then we can match key. We can try and detect char C. So if you have pressed Ctrl C, we would like to quit like the whole program, not only practice session, but the whole program. And secondly, if we detect character W, it means that we would like to apply backspace, but for the whole word. So in case of apply backspace, we are removing a single character. Well, you'll see that if it's a space character, we will remove more, but other than that, if it's a character, not a space one, we will remove just one. But for backspace word, we're going to remove the whole word. So if you made a mistake somewhere in the beginning of the word and you have typed quite a few characters, instead of just pressing backspace many times, you can press Ctrl W once and have this apply backspace word do the work for you by removing the whole word. And for char C, as I said, we would like to quit. So first of all, like should quit is true, but should loop is false. So our main should loop will be false and it will break this main loop. All right, we need to generate this method yet again, clean up this. There is no return, and to do apply backspace word. This looks good. Match key, not exhaustive for sure. We can ignore all other control key combinations. And because we have detected that it's a control something, we do early return from this function so that we don't try and do yet another matching with the key, even though the control. So pretty much control key takes precedence, right? It's more important to handle the control first, other than simple key presses. Now, there is one more thing that I showed you, I believe, in the beginning. So when the practice session is finished, so you have typed in all the text, you are shown your statistics, your words per minute and accuracy, and we are handling only 2 button presses at that point, enter and escape. So let's do just that. First, we need to check whether self state is complete, right? And if it is, then we can match the key code enter and key code escape, and just ignore the rest. And we of course do the early return. Is complete. We need to generate that. It's going to be return bool to do is complete. All right. So if we have pressed enter, we would like to quit. We have already seen how that's done. Should loop is set to false, so that outer loop, we exit that, and should quit is set to true. We want to quit the inner Ratatui loop. For escape, we would like to restart the session, which means that should quit is true and should loop is true. This is pretty much it for our handle key event. So once again, initially we try to detect if our practice session is complete. The whole text is actually typed in. Then we're handling only enter and escape. If the practice session is still in progress, we first check for control plus key combination, and after that just for simple key. And here is something that we forgot. So once the character is pressed, the keystroke is made, we want to do what? We want to actually set the start clock. So let's do that. We can say that if self state has started, and so if we haven't started yet, then self state start clock, or start clock is actually already there. How do we? I don't know, start clock, but then maybe we can rename this ones to clock start, session start, session start, session end, something like that, right? For some reason I like the name start clock. We need, this has started, we need start clock. Again, we can do cleanup. This is going to be boolean has started, and for start clock returns nothing. Start clock. All right, but interestingly, this is not it. So if we have typed in the character, and this is the last character of the practice session, we can also stop the clock. So we need to check, once we applied the character, we can check if self state is complete. We can tell it to stop clock. We can generate this method as well, do the cleanup, stop clock. And then pretty much we have to, I don't know, wait, let's do the easy way, copy this to ifs for the enter as well, right? Because if you start your practice session with enter, it's actually like a valid keystroke. We apply the char the same way as we do here, so we need to do the same checks, whether the start clock is there. If it's not, we need to set it, whether the last character somehow of our practice session is like new line, then we end the clock. So if we run it, like everything remains the same. If I press Ctrl C, it says not implemented, is complete. I wonder why. Yeah, it's because it's actually takes precedence right here. Let's implement this is complete, because it's like so easy. Is complete is pretty much just checking if self target is the same as self input. That's it, right? Once the input, so the thing that user has typed in, is absolutely the same as target, we're pretty much done. Let's run it again. I'm pressing Ctrl C again, and it quits without any errors as here, like not yet implemented. It's pretty much a clean exit. Other than that, yeah, if I press any button, it says, oh, it's not yet implemented, has started. So we will work on those methods probably in the next episode. We'll finish them off. Apply char backspace is something that we will do even further down the road. In the next episode, we will try to work on this whole UI. We will see how we can create widget, how we can split the area to manipulate the text and present it in the center of our area. Then we'll see how we can render the text more nicely, how we can use the bold white for already typed in characters, how we can use the red ones for mistakes, how we can use like grayed out for the things to be typed yet. I really hope you liked it. I really hope you're waiting for the next episode. So hope to see you soon. Bye.